And this is what we think happens. Before the macrophages start eating the myelin, they become activated in a certain way. So what we're trying to do is find out why those macrophages become activated. This is what it looks like, the so-called, what we call the preactive lesion, the first step in the formation of the lesion. These are these macrophages. They become activated. We've done a stain here for a molecule on the surface of the macrophages. When they become activated, they start expressing this molecule on the surface of the cell, and we can stain for it. And this is a higher power. And we see these very frequently in the brains of people with MS, in the areas where before the myelin is damaged. So these are seen in areas of normal myelin, let's say in the normal appearing white matter. And here what I've done here is try to draw it. I'm not such a good artist, but I'll try to draw it. Here's a neuron with the green axon with the myelin wrapping around it. And these cells are supposed to be the microglia or the macrophages, and these are normal. Now something, and we don't know what it is, triggers these macrophages to become activated. It could be something going on in the myelin itself. It could be something going on in the axon, we don't know. And then something else triggers these microglia or macrophages to group together to form what we call the preactive lesions. So this is the so-called preactive lesion. Now, because we see so many of these, it means that not all these preactive lesions go on to form an active lesion, which is a really good, let's say, target for therapy, because actually the lesions tend to resolve themselves. So that's one of the things we're trying to look at, is why some of these lesions actually do get better on their own. And if we know that, then maybe what we can do is develop something to stop these lesions or these areas developing into an active lesion. And here's the chronic active lesion with the macrophages eating up the myelin, and then the inactive lesion here. So my research is really geared to finding out why these microglia become activated and why they group together and why some of them go on to develop the active lesion. Now, one of the things we've been looking at is if you look very closely at these so-called preactive lesions, where the microglia become activated or the macrophages become activated, we know in those areas that the oligodendrocytes, so these are the cells that make the myelin, become stressed. So what we've done here, so here's a normal oligodendrocyte, here's a stressed one in red. So here's it produces a protein. So here, whoops, stressed. It produces a protein, it's a stress protein called alpha-B crystallin. And this is in a section of a preactive lesion. These are the oligodendrocytes. So some of them become stressed and some of them are normal. And here we've done a stain here to show how many of these oligodendrocytes are actually stressed. Okay, so now I've sort of tried to put everything together. These are the oligodendrocytes in a normal, so-called normal appearing white matter. And these are the microglia. These are like the brain macrophages. So something stresses these oligodendrocytes, and we know that they start expressing this so-called stress protein, this alpha-B crystallin. We know from some of our studies in culture work that stressed oligodendrocytes produce chemicals. So these are these little dots here. They produce something. And one of these chemicals is alpha-B crystallin. And if we take this protein and put it in with microglia, so macrophages in a culture dish, the microglia become activated. So that's as far as we've got. We don't really know what causes these then microglia to get together. We think that they're responding to some sort of stress signal produced by the oligodendrocyte. So that's as far as our research has got with regard to looking at the initial steps in the formation of the damage in MS. So in summary, we've learnt a great deal about multiple sclerosis by studying the brain and the spinal cord. We know that the lesions continue to appear and recede throughout the duration of the disease. So even in people that have had multiple sclerosis for 30 or 40 years, we still see these pre-active lesions. So the lesions come and go. The early lesion may very well start due to the stress in the oligodendrocytes. We don't know why the oligodendrocytes do become stressed. But we think by examining pre-active lesions, and now we're trying to develop a model in a culture dish using brain slice cultures, so actually taking slices of brains and trying to stimulate the microglia and the oligodendrocytes in certain ways, that we're trying to get a hold over what actually initiates the oligodendrocyte stress and the so-called pre-active lesions.